Question 3 is another bond enthalpy question. We are told that butane 2-ol can be prepared using two different methods. Method 1 starts with but-2-ene, reacts it with steam to make the butane 2-ol, and method 2 starts with 2-bromobutane and reacts it with sodium hydroxide to make the butane 2-ol. First part of the question is fairly straightforward. It's just a recall of a definition. So it says what is meant by the term average bond enthalpy. Really important that you learn your definitions. I mean, there's 2 marks here just for remembering a definition, but even more than just remembering it, you will then be using these definitions in calculations, and if you can't remember what they are exactly, then you're going to struggle with the calculation questions as well. So what is meant by the term average bond enthalpy? It is the average enthalpy change. That word average is important because it does vary depending on what other bonds are around. When 1 mole of bonds are broken. 2 marks for that. 1 mark for 1 mole of bonds and 1 mark for saying they're broken. Okay, more interesting bit of the question is to calculate the enthalpy change of reaction by using some bond enthalpy data. So command word is fairly straightforward. The key information in the question again is obviously the data in the table here, and the way we're going to approach this is remembering that in order to calculate the enthalpy of a reaction, we need to work out the energy required to break the bonds in the reactants and then take away the energy released when the new bonds are formed in the products. And we use the bond enthalpy data to help us do that. If you've not done this question already, now would be a good time to pause the video and have a go yourself. Okay, so let's have a look at how we do it. There are 3 marks for this question, so there's quite a reasonable amount of detail required in our calculation. So we're looking at method 1. If we go back to have a look at method 1, we are starting with butene and we are reacting it with steam. So I'm going to replicate the equation down here, but I'm going to write it as displayed formula showing all of the bonds. So but-2-ene, especially with the more complicated types of bond energy question, it's really important that you show all of your bonds because it is so easy just to forget one when you're doing the calculation. So I've shown my but-2-ene reacting with my water, and I've shown the water as a displayed formula as well, and that makes the butane 2-ol. Don't forget the oxygen hydrogen bond in there, that's an easy one to forget. Oh, there we go. So we're going to start with bond breaking. Again, I suggest you always structure these types of questions the same way. The mark scheme normally gives you a mark for the energy required to break the bonds, a mark for the energy required to make the bonds, and then a mark for taking one from the other. So if you structure your answer the same way, you make it very easy for the examiner to give you the marks. And if you make a little mistake, it's clear where you've made the mistake and you'll get credit for what you've got right. So bond breaking, well, what bonds have I got in my but-2-ene? So I've got carbon hydrogen bonds. I've got 1, 2, 3, 4, 5, 6, 7, 8 of those, and it takes 413 kilojoules to break each one, or a mole of each one of those. I have also got carbon-carbon single bonds. I've got 2 of those, one there and one there, so that is 2 times 3, 4, 7. I've got a carbon-carbon double bond, which is 612, and this is the one that lots of people forget, I have got 2 oxygen hydrogen bonds to break in my water, so they are 464 each. 2 times 464, and that all equals 5538 kilojoules. First mark in the bag. Secondly, I'm going to look at bond making. So I'm only making one product, so that's all I need to worry about. I have carbon hydrogen bonds again. I've got 1, 2, 3, 4, 5, 6, 7, 8 of those. Let me just check that. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, forgotten one. 9 of those. So that is 9 times 4, 1, 3. Plus I've got my carbon-carbon single bonds. 1, 2, 3 of those. So that is 3 times 3, 4, 7. And I've got a carbon oxygen bond, which is 3, 5, 8, and an oxygen hydrogen bond, which is 4, 6, 4. And if I add all of those together, that gives me 5580 kilojoules. And then delta HR, I'm just going to write it down here. You can't write underneath the bottom of the page in an exam paper because it won't be shown to the examiner, but I'll just do it down here. Delta HR is bond breaking, 5538 minus bond making, which is 5580, equals minus 42 kilojoules per mole. So my answer on the answer line is minus 42. So very, very easy to make a little mistake, as I did there. So a couple of hints and tips. First of all, check every carbon's got 4 bonds, which I forgot to do. So make sure every carbon's got 4 bonds. Every oxygen's got 2, every hydrogen's got 1. I would check your equation balances. So in this case, it's a quick check. 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. If I'd done that at the start, I'd have picked up that little mistake. 1 oxygen, 1 oxygen. And then just be careful with the sign. Make sure you get your subtraction the right way around. It's bond breaking minus bond making.